I actually have a very good co-presenter here because we may actually be working on a Storage Spaces Direct course with Pluralsight right now.
May or may not be.
Well, hopefully it's going to be done sometime soon if the guy named Dave would actually get around to recording his stuff.
So what's our agenda, Dave?
So our agenda, I know that there's a lot of stuff that's out there on Storage Spaces Direct here today.
Yeah.
You can go and you can check this out on Microsoft's website, the YouTube channels. The Storage PM at Microsoft, Cosmos Darwin, is probably one of the best presenters that I've seen talk about storage type technologies in a very long time.
Yeah.
He's just so eloquent. I can't compete.
And he's very young too.
He is, and he's actually an Ottawa kid working for Microsoft. First job out of school. And he's a storage PM at Microsoft. So very, very cool. So what we're going to talk about here today is just a foundational level overview of kind of what hyperconvergence is and what is the feature that is Storage Spaces Direct. Okay. Then what we're going to do is, because of the spirit of MVP Days, we want to show you guys how you can stand up and play with Storage Spaces Direct today on any hardware. Because you can actually run Storage Spaces Direct in a nested Hyper-V environment, and the functionality, like 80 to 90% of the functionality, is going to work inside of there for you. So you can get a feel of it, you can play with it, you can add nodes, you can add drives, you can actually see what's happening, you can check out the cluster health services. All of that stuff is going to work for you. The PowerShell commandlets, everything will work. Okay, and it's a great getting started because you don't need to go spend tens of thousands of dollars on
hardware that's supported.
You could actually run it on a laptop like what we're presenting on here. Like anything with like 16 or 32 gigs of RAM would be more than enough to take and stand up this environment.
And some SSD.
Yeah, all flash, of course.
Yeah.
And then what we're going to talk about is some of the routine maintenance tasks of managing your brand new Microsoft hyperconverged SAN. And so some of the things you need to do is, like, maybe you want to add a node because you're growing your business and your needs are changing and you're growing. You start with as little as 2 nodes in this configuration, and you can grow to as many as 16 nodes. And you can grow up to as high right now in a tested configuration at Microsoft, 1 petabyte of storage per pool. So if you need more than that in today's iteration, we actually had a discussion going around with some of the MVPs. They're actually just splitting it off into kind of smaller pools. By smaller pools, like 700 terabytes and 700 terabytes, and we'll just split it up like that because everybody needs 700 terabytes of storage. But there are some big use cases for that. I was actually working with a large healthcare provider that was based out of Connecticut that was looking to actually store their Commvault backups, Clint, on a Storage Spaces Direct cluster, moving away from EMC Isilon.
Oh, wow.
So, and their big requirement was they needed like 2 petabytes in a single namespace. So that's a big blob of storage. All right, and then what we're going to talk a little bit about is how you can actually stress test your own environment using disk speed. So we kind of alluded to this a little bit in the previous session. And I've got some really cool demos that we're going to go through. I wasn't sure how the internet was going to behave because I've actually got my servers in my lab back home, and sometimes I live on a farm. And so sometimes over the wireless shot, my internet goes up and down, so it doesn't necessarily make presenting all that great going in for live demos. So I've actually recorded some of those demos, but I think the recordings are pretty solid. Nice and short, compact, so I can show you like 30 minutes of stuff in 5 minutes. All right. So introducing Storage Spaces Direct. So the favorite part about Storage Spaces Direct for me, Clint, is this. What are we looking at there?
That's just Windows Server, an unactivated copy of Windows Server, to point out.
It is an unactivated copy of Windows Server. And all of a sudden, the server has some writing on it. What is Storage Spaces Direct? So think of your server asking you this question right now. What is Storage Spaces Direct?
It's a feature. It's a feature within Windows Server 2016.
Wait a minute. You don't need to download it?
No, you do not.
It actually comes with the ISO?
Yep, it's fully included.
No way.
Yeah,
seriously?
You can have your own SAN, no longer have to worry about any sort of external storage device because it actually runs on commodity hardware that you already have in your data center today, and it is baked into the kernel.
It is baked into the kernel, so it is right there. It is part of the operating system, part and parcel. So you don't have to go grab something, license additional. So if you're already licensing Data Center Edition, I have great news for you. You already own this. So if you're on SA with Microsoft and you get the latest and greatest versions of the new OSs, you actually own this feature and it's actually free to you. Okay, it does only ship with Data Center Edition at this time, so it's not available Standard Edition or earlier. So if you want to run this, for example, and it is supported on a Nano server, by the way, but you still have to license Data Center Edition even for your Nano instance. Right. So I always get that question quite a bit. So when we take a look at this, let's just go through a quick walkthrough of what it takes to build this, because conceptually, this can actually be very difficult to kind of understand.
Well, the first time that I heard it, it was definitely a little different to think about the way that Microsoft has traditionally done storage, because this is very, very, very different.
Marcos, what are we on for slides? Are you on us or the slides? Okay, can you go on the slides? Awesome. Okay, so now how exactly does this work? So this is how this works, guys. Everything is considered a concept of shared nothing infrastructure. So basically you take commodity infrastructure, commodity servers, and we're gonna pool those together, take all of that direct attached storage, and we're gonna create our own SAN, okay? And this is what it looks like conceptually. And I have to give full credit to these slides to our good friend Cosmos at Microsoft, because he does a great job at doing these 3D vectorized.
But he gave us full permission to use them.
Yes, he did.
Yes.
So the very first thing we have to have is we have to have a couple servers. The minimum configuration you have for storage spaces direct, folks, is 2 servers. And it scales up to 16 servers or nodes at this time, okay? So you don't need to have 6, 8, 12 servers to get started. You can get started with as little as 2. And I've actually played around with the configuration, guys, where I want to get that RDMA technology that we've been talking about in the earlier sessions, Clint, working without having to go break the bank. So I went and I bought some of those Mellanox cards that I said would work with RDMA, and I just used the direct attached cables, and I just basically crossovered them between the 2 nodes. And so now I get full 10 gig connectivity, RDMA connectivity for my 2 servers in the lab, and I didn't need to go spend $5,000 to $10,000 on a 10 gig switch. It cost me $600. Now I've got an actual nice little test lab. And that's actually where I did most of my testing for the demos that you're gonna see. So I know it works, okay? So let's say in this example, we had 3 servers.
3.
And these servers, we wanna make darn sure that these servers are on the Windows server catalog.
Right, that's very important.
Supported by Windows Server 2016. So although the older generation servers may install, you want to make sure that this is supported. Because if you're going to go into prod with any of this, you want to make sure that if you ever have to phone Microsoft, they're not going to come back at you and say, well, you just installed components that actually are not on our supported compatibility.
Right, and that's an important thing to call out, because more and more vendors are going through the certification. So if you're looking at a specific, RDMA NIC or a specific hardware vendor or a specific server model, right? You need to make sure that it is absolutely 100% certified. I think a great example is HBA cards, right? Dave mentioned earlier, it can't be a RAID card. It has to be a simple HBA, making sure that all those components are certified.
Okay, so what we're gonna do is take those 3 servers, plain old servers. You just ordered them from CDW or SoftChoice or whoever your favorite reseller or VAR is, and they just landed. The boxes are there. You just racked and stacked these 3 servers. You just put a few drives inside of them. You can start with as minimum of a configuration as 4 drives in each of the servers. It actually works with as few as like 2, so I've gotten it working, but Microsoft doesn't recommend that because the expansion of the pool is a little difficult. Sure. So you can do lots of things that are outside the lines. And so what we want to do with those servers is we're going to cluster them.
Right, so first we would install Windows Server 2016, Data Center Edition. Then the second thing is we would build a Windows failover cluster.
So now we have a 3-node Windows failover cluster. Failover cluster manager is working. We can take and set up the quorum. It's the same type of thing you do for a SQL cluster or an Exchange cluster or a file server cluster, Scala file server cluster.
But don't do anything with the disk.
Yeah, so you're gonna do nothing with this. You're just gonna set up the failover clustering. It's 1 line of PowerShell, new cluster. That's it. You don't touch it beyond that. You just stand it up, okay? Quite literally, you build storage spaces direct with probably less than 10 lines of code, like PowerShell. It's crazy how easy this is to set up. And then what we're gonna do is we're gonna take all of those disks that we have and we're gonna pool them together. So Microsoft built a special PowerShell commandlet for Windows Server 2016. That special commandlet can either be run 1 of 2 ways. Can run enable - cluster storage spaces direct, or cluster S2D. That's it. So you just run that command, and it'll actually automatically set up all of your tiers, your pools, everything in a default configuration. Now, if you don't like the default configuration, you just set autoconfig equals false, and then you do it yourself. You build your pool, and there's 3 extra lines of PowerShell you have to run.
So you mentioned tiers there.
Yes.
So the concept of storage space is direct. It runs on commodity hardware with internal disk.
Yes.
So in that I could have NVMe,
yes.
I can have SSD, and I can have spinning HDD drives. And with that, whenever you have the enable auto configuration on by default, it'll actually choose the fastest disk and use that as the performance tier, and then it'll use the less performing. If it's SSD, for instance, with NVMe, it'll use that as your capacity tier.
It auto configures your cache for you. You have to do nothing.
Right.
So if it sees SSDs and HDDs, they're called journaling disks. The journaling disks get set and defined automatically. And we're going to actually show you this configuration. I'm going to show you the script that we have going through. So now we've taken those regular good old JBODs. So you guys know what a JBOD is? JBOD is just a bunch of disks, right? It's all the DAS drives that you have sitting in your DL380. You get like 24 drives that you have in the front. Think of just loading those up with disk, and now we can take all those disks and we can actually form the pool. And we can do all of this automatically. So now that we've formed the pool, now the important part is what do we want to do with this pool of storage? We want to take and carve it out into logical drives. So for me as a Hyper-V guy, I know these as cluster shared volumes, or CSVs. So all that we do is we run one line of PowerShell called new volume. New volume. Specify the space that we want inside that volume. Let's say 400 gigs or a terabyte. And I say, what file system do I want to run? I want to run CSV REFS. So I want to use the brand new file system 3.1 with Windows Server 2016 and all the inherent benefits that come with that we learned about earlier today. And bam, that drive is presented as volume 1. That's it. It's like 3 lines of PowerShell, guys, and you have a CSV. And once you have that CSV, you can do anything you want with it. You can store files on it. You can store VMs on it. You're good to go. So quite literally, that's your process that you run through. So we take all of the pool of disks, we create volumes. Then what we do is we're going to have all of these volumes that run together. Now, the best part about this, Clint, is these volumes have built-in resiliency. So when you create your volume, you can choose the level of failures that you want to be able to survive. So the least amount of failures you could survive is what's called a two-way mirror. It's a traditional RAID 1, okay? Makes sense? Everybody know what RAID 1 mirroring is in here?
The thing that, the reason why, so I want to point out a key thing here that folks might not realize is the reason why you don't have a RAID card is because the Windows Server operating system itself is going to function as that RAID inside of the software. So you are building a software-defined storage array, if you will. So whenever Dave talks about kind of pulling the disks together, creating volumes, do I want to have a two-way mirror, a three-way mirror, parity, two-node parity, three-node parity? There's pros and cons that we talked about earlier today if you're in my session based on which one of those you want to go with. But just understanding that this is software storage-defined kind of hardware, a RAID device.
How I like to explain this to people, Clint, it's like RAID 1 over the network.
Yeah.
It's like RAID 6 over the network. That's basically what you're setting up, because I need to have a network cable plugged in between these things so that we can talk, so that they can now mirror and replicate the storage behind. That's one of the reasons that we want to have those RDMA adapters, because although we can set this up with regular old, I've actually set this up on 1 gig server, so I've taken servers with just like 1 gig connectivity into like a regular Cisco 3560 switch. It actually does work, but what happens is when the storage goes to replicate, your CPU just goes through the roof, like 70%, even on the hosts, right? So with RDMA, you just cut all of that out, all right? So now what happens, Clint, if some of these drives die? So let's say that we have drive failure.
Yep.
What's going to happen?
Well, that's if you have the mirror, you've got extra copy
Yes.
of that data on disk, or if you're using three-way parity, triple parity,
Yep.
right? It's going to automatically rebuild whenever
Exactly.
you've got those parity bits written across the extra volumes inside of that storage array.
So let's say, for example, we had a two-way mirror. You can actually lose all of the drives in a single server. You can lose the entire node. You can actually power the node off physically. So let's say that node had 24 drives in it, and you were running a two-way mirror to another server that had 24 drives. All of the data is striped between both servers. If you physically press the power button as if you had some catastrophic failure, like you're popping capacitors on the motherboard or something that's not fixable, you will survive that. Your failover cluster manager will go online. Any of the VMs that were running on that other node will take and will fail over to the other node. Yes, it is a hard failure. You can't survive. There's no time to live migrate because it's a hard failure, right? So that's in the event that the whole node dies. But if just a few drives die, it's a survivable instance.
But kind of the caveat there with the two-way mirror is you're sacrificing 50% of your
available
capacity
space
because it's cut in half for reserve.
Yeah. And so we can take the same theory in a three-way mirror, but now we're only getting 33% of the usable data. So let's say, for example, you had 100 terabytes, 33 point whatever percent would be viable for you as raw storage. The rest is for the other two mirrored copies. But I could lose two servers, right? So in this example, it's just basically a single server. And so as the drives get replaced, it actually self-heals. So if we pop those drives out in a failure scenario and we pop new drives in, the cluster health service actually detects those as new drives in there and will rebalance and will restripe that out. So it actually writes in 256 meg blocks across all of those nodes. And you're gonna leave here with a word, okay? The word is called parallelism. And so what it does is it writes to every single drive simultaneously, right? It doesn't just say, oh, these three and these three and these three. If it's part of the pool, it stripes across.
That's one of the key differentiators,
so
actually.
The bigger it gets, the faster it gets.
As storage space is direct to other hyper-converged products out there. And the way that this parallelism works, because now you're able to leverage all the performance of all the disks inside all of the servers, right?
Yep.
Were you going to ask a question?
Yeah. So you lose a drive, you pull one out, you put a new one in, and it picks it up. Is that just on a port-by-port basis? Like if you added, say you had 20 drives in a 24 port, and you added the 21st, would it pick that up and add it in too? Or would you have to tell it to?
No, it would add it to the pool. It'd see the drive has failed. If you knew the drive was failed, you just run one line to set it to retired.
Way to add a drive in and not have it added to the pool automatically. Like if you want to add in a drive just as a second drive or something.
Yeah, you can set the usage type before it picks it up. So you can set it, instead of being auto, you can say that it's a hot spare or it's manual.
You could tag it
yeah. So
you'd have to do it in advance.
there's like 4 types inside of there. There's like auto, there's journal, which is cache, there's manual, which is manual, or there's hot spare. So you can define hot spare inside of there. So you set that when you actually plug that in. So let's say you plugged in a brand new node with 24 more drives. It would actually pick them up as available, but you'd have to go tag them quickly because that cluster service, as soon as that node is added, it says, woohoo, I got all this extra space. I want to build a bigger pool. I was 100 terabytes before. Now I'm 200 terabytes.
Do you tag it as a whole, like as a CSV, or do you tag each individual?
No, the pool of storage is not part of the CSV. You carve the CSV out as the virtual disks and volumes out of that generic pool.
Yeah, I meant the pool itself.
Yep.
You tag the pool, or do you tag the drives individually?
You would tag the drives individually.
Okay, so
Yeah. Yeah, because I found that actually runs really fast in behind. There's timers in behind there. So like within 5 to 15 minutes, it's starting to provision all of that stuff. And I'll show you some of the commands. I've got a demo. I've got a demo of all this stuff. So I promised you guys that I would give you a look at what it's like to build this in a nested environment. So what I've done is I've actually captured and time-lapsed the build of, I think we had a 3-node storage spaces direct cluster. And I'll make this PowerShell script available to you guys. This is just a community script. How are we doing for time?
I'm not keeping track.
Okay. So guys, what I'm going to show you guys, even if we have to go over time, we're at break anyways after this, aren't we? Yeah, I think we're at.
No.
Who's next? Oh, it's okay. It's just a meal. So what we're showing you here is basically I've got an ISO image. I've got a folder called base VHDs. So if I run this script and I just have the ISO and my big lab 3-node script, it'll actually go and build my base VHDX files that will be used to provision the rest of the lab. So I've kind of skipped that step because I didn't want to see you guys seeing a progress bar in there, because it takes like 20 minutes to like provision the gold VHDX and sysprep it and do all that stuff. So my gold VHDXs are created at this point in time. So I have some base virtual disks that I can use to build my lab. These are just 2016 Data Center Edition virtual disks. That's it, very simple. So now I run my script. I have to define a working directory. This is where I want to actually store my VMs. So for me, I'm going to store them inside of an existing storage spaces direct configuration in C drive, cluster storage, volume 1, DC build. That's where I do all my work inside of here. So I take and type that in, DC build. I take and I put in the organization name. So we were doing some work for some of our coursework, so we called it like company.pri, whatever. This is a domain name, because this is actually going to stand up a domain controller. This will build AD, this will set up a DHCP server. It'll build all the underlying infrastructure that you need to set this up in your own lab, and set up an internal vSwitch so that it'll all connect via a private vSwitch, so that it'll all connect and just be like off the network.
There's your super secret password.
That is my super secret password. And can you actually turn off the live stream, Marcos? No, I'm just joking, because that's my banking password. Okay, so we call the domain company.pri. I give a virtual switch. So this just creates a private virtual switch because I need that lab environment to actually be able to talk to itself. So I just call this company vSwitch. And then if I want, I can take and specify a subnet range. And the subnet range will be, I think in here, like 172.16.200. And in my script, you just have to put a dot at the end. So just make sure you do that when you run this. And extra lab files if you want to customize the script, which there's nothing to actually in there for extra lab files. And you go ahead and you press enter. And now all of a sudden the magic begins. So now it's provisioning. If you look at the right-hand side here, I've got DC1 that's provisioning, and I've got that domain controller starting up already. DC2, because why not have 2 domain controllers? 2 is better than 1, right? So your choice. You don't need 2, but I wanted to have 2 as part of the lab. So I built 2 domain controllers. I stood up a server as a DHCP server in here, and I stood up a management server because I wanted to have like failover clustering tools and stuff like that installed, because my script will actually work on Core or Nano Edition as well. So I haven't done as much testing on Core and Nano, but if you had Core, you're going to need something with your management tools. So that's kind of the premise of why I built like that. 'Cause some people are like, well, you could have just put that all in your domain controller. Yes, I could have, but I wanted this to look a little more realistic. So now it goes through and installs AD. This is the fastest Active Directory install ever because I've time sliced this, and all the reboots are saved for you. And so now this built my company.pri. And so we see some lovely work. And our fellow MVP, Thomas Rayner, PowerShell MVP, actually helped me clean up the code so that you actually see some better output and dialogue in here, because I always like to tell him that my code looks like chicken scratch when I start, and his job is to make my code look pretty. So this is what you're looking at.
So you'll actually see here now that it's actually building out the storage spaces direct cluster nodes. Now, granted, this is nested.
My server's big. Like the server I'm building this on has 192 gigs of RAM. And so I gave each of the nodes 16 gigs of RAM because I was actually testing inside of here. But you could build this on 2 to 4 gigs of RAM. It's not a big deal, okay? And so you go through and you build this, and it finishes the build process, takes a couple seconds. Now it's actually running that command I told you, enable cluster S2D. Then I go ahead and I log into one of the nodes. I'm actually a really fast typer because I can actually do this with magical powers of not touching the keyboard. That is something new that you guys are learning right now for how to fast track a particular demo. But I wanted to just show you the finished product because you want to get started with Storage Spaces Direct, and this is what you're going to have. You're going to have a 3-node cluster. You notice how I had S2D 1, 2, 3, and 4 in there? I didn't add the 4th node because I wanted to have that as a demo for later on, because what if you wanted to add another server inside of there? And so the beauty about doing this in Hyper-V, you want to play around with adding drives. It's as simple as adding a virtual hard disk. So you go new virtual disk, and you just provision it and attach it to the box on the SCSI channel, and all of a sudden, it picks it up. And you actually can go get physical disk, and you can run all the same commands that you would as if you're actually removing and ripping, pulling the drives. It's all the same. You're just doing it all virtually. So I think that's pretty cool. And you can see that I've got a storage pool that's built here. So this is the way that it presents itself. And inside of my build, I actually went ahead and I set up some cluster shared volumes. So I think that's pretty cool, Clint. don't you? Now let's take a look at some of the common maintenance tasks. So now I have a Storage Spaces Direct cluster that I built with this great and wonderful script, and now I want to take and I want to do some maintenance tasks. Node 4.
That's a really nice shirt you're wearing. I just want to point that out.
It is a very nice shirt.
Sorry, got diverted.
I thought you were looking at my boobs there.
Not really. Where'd you get that shirt again? Just curious.
I don't know. It's like Craft Ninja.
Yeah.
Yeah. Clint's
My wife actually makes this stuff for a living. That's what she does. Yeah.
What's that?
That makes it even better.
Hey, we're MVPs. We can do whatever we want. That's right. What's that? But you just
so adding a storage spaces node to our cluster. We'll go through and show you how to do that here.
So now I've built my 3 node, we've expanded, I want to add a 4th node. So if you guys, I write this really slow inside of here so you can pay attention. So I run get physical disk. This is a really important command because, no, you can't touch that because now I have to run get physical disk because it's a really important command. Just wait, no, don't touch it. Don't touch it, it'll go, it'll go. Now you broke it. Clint, why do you touch my machine?
Just
Paused.
There.
I was trying to pause it.
There.
Talk.
So get physical disk is a very important command for us inside of Storage Spaces Direct. Why? Because it'll actually show me all of the disks that are available inside the cluster. So right now I've only given 2 drives to each of the nodes inside of here. And you notice how it says can pool equals false. That's because they are already a member of the pool. So when I go to add the new node will have 2 additional drives available to it. Okay, so when I run get physical disk, after I run this single line of PowerShell code, which is add cluster node, you guys want to write that down because this is very complicated because that's how you add a node to Storage Spaces Direct. And what this is going to do is just add it to the cluster. But because the cluster is already aware and running Storage Spaces Direct, it will then attempt to go grab any of the available disks because it assumes that you're adding something into the pool. Okay? So it's very important to understand that when you're running Storage Spaces Direct, there's things that are happening with the storage behind the scenes, that it's going to go grab your available storage, okay? And so we take a look inside of here. I can see that I've got a node that's actually joining. So I've got S2D node 4. It's actually joining the cluster. So this will just take a couple seconds. I think overall it takes about 30 to 45 seconds to join the cluster. After this is done, I can go get storage health action. This is also a very important PowerShell commandlet because this will show me what's happening behind the scenes because there's health providers that Microsoft has written specifically between the storage team and the failover clustering team. They wrote storage health providers so that the failover cluster service could hook in and see what's going on. So that's why I need to run that because then I can see what's actually going on. I can see if jobs are failing, and then you can run get storage job. And so get storage job will actually show me in-flight jobs. And I actually showed this with nothing there because you have to be really fast. So I missed it. So the job was actually done. It ran so fast that the job was done. I go get physical disk, and boom, all of a sudden, I could see that one drive was connected, and then the other drive was in here. So see how this one said true? I time sliced this a little bit, guys. So when I ran get physical disk, one of these said false, one of these said true. I had this one drive that just wasn't picking up properly inside of here, so I had to kind of finish it off. But that was it. So basically, I just add that node. I wait for all the disks to go from true to false. They're part of the pool. If I went into failover cluster manager and checked the pool size is now increased. It's one line of PowerShell. That's how you expand. You want to go to 16 nodes? You could actually just concatenate that and just run that across all your nodes.
But they could actually not have it automatically add the disk to the Storage Spaces Direct cluster too.
Yes. Yes, you could. Okay, so now the next one is debugging Storage Spaces Direct and adding disks to and expanding the pool. So this is where it's saying you can just go through a single line in PowerShell, and I can just drop additional drives inside these nodes and just watch to see what it does. Envision yourself having a DL380 and just going pop, pop, pop. You're just popping in new drives. That's all you're doing. And this is the reaction that the system is going to have in behind the scenes. So first thing that we're going to do here is we're going to take and, okay, I'm not paused, good. Remember, we're going to have some specific commands we're going to run. Remember that get physical disk? So I run get physical disk. So now I can see that everything is looking good. All of the drives that are available are already part of the pool. Remember, I haven't added any yet, right? So then I'm going to take and I'm going to run get storage health action, because then I can see the list of anything that's going on inside of my Storage Spaces Direct cluster, right? Now the next one here is kind of cool, because what you can do is go get storage subsystem. You can hook into your cluster, Then there's a couple debug commands that are really cool inside of here. So I see that, okay, get storage subsystem cluster, that's its name, cluster. And then I can go debug storage subsystem. And this will give me all the in-flight alerts. So this is what you have to do if you're like popping drives out and you're seeing drive failures. Drive failures will show up inside of here in this debug. And that's how you pull this information out, because it's not necessarily going to show up in the UI. It will show up in the event logs. But this is where you can just go see if there's anything broken. So you hire me, Dave the consultant, to come fix your S2D world that you've now just built. I just run that one command and I can see if the thing is crapping out on you, right? And so now all that I'm going to do is I'm going to drop a couple extra drives in here, okay? So I can go new VHD. I can say I want to add data disk 3 and 4. I want to take and I want to add this to one of my nodes. And then I'm going to run what command again to see what the disks are? Get physical disk. Now watch what happens when I run get physical disk. Get physical disk. So now watch what happens. So now you see the 2 that are in there is true, because those are the 2 that I've just added. Now you wait a period of time. So I go get storage job, and I go get storage job, and I can see, oh, I found a new drive. I'm adding the new drive to the pool. You can actually logically see everything that's going on. All of this is documented inside the failover clustering storage subsystem log in the event viewer. So you can see everything that's going on. It'll say, found new drive, disk, blah, 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 adding disk, blah, blah, blah. And it'll do all of that. All of this is automagic, guys. I do nothing inside of here. This is the beauty of Storage Spaces Direct. So now what I'm doing is I'm actually watching one of the jobs run. So I'm watching one of the jobs run, and then I keep running this, and one of the drives wasn't picking up, so I had to like manually add it inside of here. So what do you guys think of that? That's pretty cool, right? Now my favorite demo is Windows Server 2016 has built-in resiliency and health checking capabilities for your cluster. Have you guys ever had a cluster node that all of a sudden is having blue screen issues and is in like a looping blue screen because some driver barfed on the box? Have you guys ever had that issue before, where it just loops? It lives for like 2 minutes and then so.
Or the periodic blue screen was my favorite.
Yeah.
It's just completely random whenever a certain condition gets met.
Yeah, you guys get where I'm going with this, right? So you have that server that is like trying to join the cluster, but then blah, trying to join the cluster, blah, and it just keeps going in a horrible cycle. So what Microsoft has done in Windows Server 2016 is they built in what's called the cluster quarantine. And so if it detects 3 failures in a row, it's going to actually quarantine that out. And so we actually have a kind of a little cool script that we can run for this, and I can share this with you.
But this isn't something that's native to Storage Spaces Direct. This is actually what's with
This is failover clustering.
Yeah, Hyper-V 2016 provides this capability.
Yeah, well, the failover clustering service, yeah. So we've got a cluster resiliency demo. And so the first thing that's going to happen is, boom, your server's going to go down. Do you like that? I kind of like that script. No, just wait, it gets better. Because now what you're going to do is you're going to let it start back up, because that's what happens when something blows up. It's going to start back up. So let's start that back up. And then it's going to crash. So you can envision a blue screen of death hammering you right here. You know nothing about what's going on. It's probably not a good idea, so we can see that it's down again. Up, down, up, down. How many times that happened now? Twice, right? Watch what happens on the 3rd time. It's going to actually go into a quarantine state, and if you check the event log after it goes into a quarantine state, it says that it's going to live in a quarantine state for X amount of time after it comes online. So all of a sudden, this is one of those things, hurry up and wait. So you wait X amount of hours, and all of a sudden this thing will just try to come back alive, because it's waiting, because it doesn't want to keep doing this, because it could be like live migrating rules around. Like if you had affinity rules inside your cluster, it'd say, put these critical VMs back on node 1. We love node 1. But node 1 keeps blowing up, so everything keeps moving over. But then it keeps trying to move everything back. And it's not very pretty inside of your cluster. So then you can clear the cluster quarantine, and this is just, we just wanted to show kind of a cool new feature of Windows Server 2016. It's very important for the resiliency of S2D, because now I'm mirroring all this stuff. So if I'm like in flight mirroring that data and it's not done yet, that's probably not very good for your cluster, right? So that's why I want to show that, because it's to prevent you from shooting yourself in the foot. Yes, question?
Regarding the just resiliency of the actual nodes themselves, I'm assuming with the C drive, you still want to have a mirrored drive for that.
Yeah, for sure.
It's a totally separate environment from the actual storage space, correct?
Correct. So the question was,
do you want to mirror your C drive still? In optimal terms, yes.
Just
vendors.
What uptime are you
Or
hyper-converged vendors right now, that I won't mention any of them, they build these 4-node boxes in a 2U chassis. Lots of them that are out there. Supermicro makes these chassis, okay? And so most of those, what's going to happen with them is they're going to boot off what's called a DOM, or dongle, on the motherboard. There's no resiliency on that. That's like taking a USB stick and booting off of that.
VMware, I'll throw
Yep.
a
thumb drive and install it on there, exactly.
Technically speaking, these are disposable pieces of hardware. So if they blow up and die, it's actually very easy to replace node 1 with node 5. You just drop node 5 in, you provision it, it'll just grab the space, it'll re-tier, you just evict node 1, done. So
still need a dedicated hard drive for it. Like you can't just.
Oh,
this isn't
yeah.
running in memory the way VMware.
No. This is actually going to run. Okay, so the last thing that I wanted to show you with my demos here, guys, and I hope you understand why I scripted these demos like this, because I'm actually showing you stuff that could take hours if I wanted to do this manually. The next thing I want to show you is you got to get yourself a copy of what's called VM Fleet. So just a show of hands of anybody that's heard of VM Fleet before. If you're not an MVP, then put your hand down. All right. So VM.
Nobody in the room raised their hand.
Have you guys heard of SQL I/O before? Has anybody heard of
Yes.
SQL I/O?
Yes.
So disk speed is kind of the next iteration of that. And so what VM Fleet does is it has wrappers around disk speed, and it actually provisions virtual machines to run that just sit there with a watcher service. So the only thing you need to make this work is you just need to install Windows Server 2016 or whatever OS you want to test on. So think if you wanted to test your VDI Windows 10 instances or something like that. The only thing that you have to do to test this is, and we're going to clap louder than him because this little game.
Because that was Thomas
guy,
playing a silly little game. That's absolutely what it was.
So basically what you're going to do is build out a VM, and you're just going to put in a password. That's all you need. That's it. So you just need to define a password inside that VM. You don't sysprep it, you don't do anything because the tool does it for you. It has a whole set of wrapper scripts called create fleet and do all of this stuff. And so it'll build as many VMs as you want with as much RAM and everything. So I did this. So I actually simulated this. So I've got my VMs pre-provisioned because they do take a little while to pre-provision. I've got like a couple on node 1. I've got some on node 2. And this is my favorite command in here. It's called watch cluster. It comes as part of this. Check this out when I run this. So I run watch cluster, and it actually checks the in-flight IOPS on my nodes. So as Storage Spaces Direct is doing like rebuild operations, I can actually see how busy these things are because those are like real-time reads inside of there. This is 100% free, okay? Then I've got another command that I can run. It's called test cluster health. And so it's going through and telling me, oh, Dave, you have a couple of RDMA supported NICs in there. This is the direct to server, direct connect thing that I have at home. This is what I'm playing with in my lab. Okay, so this is a 2-node S2D that I'm testing on. 2 nodes, and I'm using only commodity flash inside of here, okay? So I'm using like off-the-shelf 1 terabyte drives, which is a really bad idea, and I'll get into that later, because you want to make sure that those things are enterprise SSDs, because you do. Okay, so now I check this, and it looks like everything's good. So I run test cluster health, everything's good, everything's happy, right? And so now I want to actually kick this bad boy off. So I'm going to actually go kick off a little test inside of here. So we scroll down, I'm checking this, blah, blah, blah. I thought I time sliced this a little bit better, but that's okay. It's my first time running through this. By the time I hit Vancouver and Calgary, this is going to be like boom, boom, boom. We're good. Okay, so I want to actually run this. So the first test that I'm going to do, first thing I'm going to do is I have to actually set VM Fleet and the processor count. So I'm actually going to modify those virtual machines. So I'm going to change the number of procs, change the number of RAM, change all those settings inside of here. So I'm defining what my test cases are going to look like. So if you're building VDI and you want to test your SAN to see what it would run like in pre-production before you actually hit the real world, and you want to push this thing to its utter limits, you can push this thing to its utter limits. So I say set VM Fleet. I want to give each VM 16 gigabytes of RAM. Sure, why not? It's my lab. I can do whatever I want. I'm a VM. I'm an MVP. I can do whatever I want. So now I go start VM Fleet. So now what this is going to do is it's going to actually turn on those nodes. Okay, remember, VM Fleet is free from Microsoft. You just download it from GitHub. It's okay if we go over by a couple minutes. It's just a meal. What's that? Who? Oh, is it you? Okay, we won't go over that. I'm almost done. You can go late. So now I started this. I tell you, I'm almost done. I did actually have a failure on one of the nodes, but I didn't have a chance to fix it. And so now I can see that I'm actually generating a boot storm here because look, I'm generating about 15,000 IO on the boot storm. And now I have to clear a pause because there's a watcher service inside. So I'm just going to go jump into one of the VMs here. I'm just going to show you what it looks like inside of one of the VMs with the watcher service. So I'm just going to go grab this node 1 VM that's been created inside of here, connect to it. And I just want to show you what the PowerShell watcher script looks like. So this is the watcher script that you're seeing. Server Manager is kind of hiding this. But basically, you're going to see this as soon as I say, go start the test. You'll start to see this interact. So basically, the script is going to go interact, and it's going to go drive disk speed inside of each of the VMs. So these tests that you're going to see are actually driven from inside within the VMs, not just outside the VMs on the CSV. These are like real-life tests that you're looking at. So I start a sweep, and this is a really bad example because I'm going to run this with 100% read. Let's see what my read performance is of Dave's little 2-node S2D configuration. And I can see a couple little things going on here, and watch this. 70,000 IO. And here's me back into that other VM. So as soon as this kicks off, see how it's actually kicking off? So it's running my session to 130,000 IOPS, 150,000 IOPS. This is 2 nodes. I only have 4 drives in this server. This is all running on like commodity SSDs. So I'm just waiting for these things to just go 192,000 IO. Wow, that's pushing a lot of data between those nodes, right? So let's go check out some RDMA counters here. Check this out. So RDMA is saying, wow, I've actually got some counters going and I'm seeing all this traffic going out over RDMA. RDMA is your friend. You want to see this stuff. The reason is when I go check Task Manager, I'm moving a lot of data here, guys. Check my NICs. What are my NICs doing? Nothing. CPU is obviously going to be up because I'm running a stress test, okay? But if you're just doing regular file copy operations, it's not touched that much. And watch disk. So when I go to disk and I'm pushing 200,000 IO, that's not what I'm expecting to see.
Look at the reads there on the left.
Yeah. Pretty cool stuff, right? So now the next test that I'm going to run is going to be doing a 70-30, right? So that's more of a prototypical test, right? So we're going to do a 70-30 reads writes, and we're going to see something substantially different here. And what's going to be substantially different, I'm just going to fast forward this a little bit because Marcos has to come up next. So I just changed this test now. So I just say that the writes are going to be 30%. Blah, blah, blah. But what I did is I actually discovered a problem with my configuration. My configuration wasn't giving me what I wanted. So I ran this, and I was actually only able to sustain 15,000 IO. I should get way more than that in this particular type of configuration. But what I was pushing, if you saw the last one, I was actually pushing a gigabyte a second. I don't know if you guys caught that in that last test. That was pushing full gig. I was getting full line speed on that 10 gig. Right? Now look at what I'm getting.
36 megabytes.
I'm going to think that I probably have a bit of an issue with my configuration here. Now, I wanted to show you guys this for a very, very good reason. Okay, the good reason I wanted to show you this was the fact that you can use this test case to prove that you've got hardware problems. I have hardware problems right now. I have driver problems. I have something wrong with my configuration because there's no way that that should be that crappy a performance. What's going to happen when I go through a big VDI farm inside of here?
Puke.
It's going to puke like as soon as I get like 20 to 50 VMs inside of there. I know that right now. I need to fix this. So that's why I wanted to capture this, because normally I cut this out of my presentation, but I wanted to show you this because it's actually a very useful testing and remediation tool, because now, once I fix this, guess what I do? I run the same test.
What do you suspect is the problem?
I'm at like a DAC connection between the 2 nodes, and I'm actually running a set team, so I actually have both adapters. So I actually have a team configuration, and I don't know if that's actually supported at all. So, all right, okay. So Marcos is giving me the big fish hook here. I'm just gonna wrap this up. Hold on. Cancel. Come on. Oh yeah, that's it. We're done. Okay, last thing. Who's here is coming to Microsoft Ignite? Anybody?
Anybody?
Anybody
Yeah.
coming to Ignite?
I'm already signed up.
First thing you need to do is you need to look coming to Microsoft Ignite. Great conference. 25,000 of your closest friends are going to be there. It's in Orlando this year. Bring the family. Come to Disney World. Come to Microsoft's biggest conference. If you're coming there, or you know somebody that's coming there, we host an event there, and it's quite literally the coolest event at Microsoft Ignite because we run a hockey game. It's a beer league hockey game. It's just an exhibition game that we play. And if you don't play hockey, that's fine, because you can just come as a spectator, because we're going to give you beer and we're going to give you light up maracas and you're going to cheer, because that's what we do. And there's live play-by-play by Clint, yours truly.
Although I think I might play this year.
Oh, nice. Right on. So, guys, I'm going to turn this over to Marcos here. He's got an amazing session on Azure site recovery. And guys, we need to be louder than them for the applause. What do you guys think of the session? What's that? Yeah.
Control for you.
Well, you know what? We'll throw in a bonus session. Do you want to do yours? If you don't want to do yours, just hit end stream. Here, let's just thank everybody on the stream first. All right, so let's go thank everybody here. Clint, grab the mic. All right, so put me on the camera here. All right, so for everybody that was tuning in live, that's going to be a wrap for all of our general sessions at MVP Days 2017 Edmonton edition. We really hope that you guys enjoyed the content. Any of your feedback or comments are always greatly appreciated, and we hope you join us again. We're going to be live again on Friday, this coming Friday from Calgary, and we're going to have a different track and all new sessions for you. So guys, thank you very much once again. This is going to wrap up our probably 7 straight hours of streaming of MVP Days for the very first time. Almost 8 hours. Thank you guys very much. See you later.